So what I'd like to talk about right now is ESD footwear, and that is one of the newest standards that has just been changed. We've been operating under the ASTM 2413-11. The dash 11 means the year that the standard has been published. Now there's a 2413-17 standard. That means it's been published in 2017. And the major change has been in the category of ESD footwear. Historically, ESD footwear was tested between 1 and 100 megohms. Now, what we were really trying to do is test how electricity or electrons flow off the body. So let me step back and talk about what static electricity is. We've all been outside and we've seen lightning. And lightning comes down out of the sky and hits a tree, and the tree falls over and burns up. Okay, well, or it hits a building, and that can cause a lot of damage. Static electricity coming off your body can come down on a microchip that you might be working on, and the effect is the same as the lightning striking a tree. That lightning that strikes the tree destroys the tree. The static electricity coming off your body and hitting the microchip destroys the microchip. So if you're making a cell phone and that microchip that has been hit by static electricity could be destroyed, when you put that microchip chip into the phone may not work. So static electricity, static discharges off the body are very important in the manufacturing of high-tech equipment. All right, so now we have static electricity building up on the body, and what we need to do is we need to get it off the body. So we now test footwear for its ESD properties, and we want to measure how well the static electricity that's building up on your body for your shirt rubbing, how well that static electricity flows through the shoes. So what we're trying to do is get the static electricity off the body through the shoe, then onto the floor, and then from the floor to the ground. So the first level of static flow is through the insert. So if you look at a shoe, you'll see that the insert has conductive stitching, so through the insert. So the static electricity can flow off your body, through your foot, through the insert. Then it flows through the midsole and through the outsole, and eventually will touch or flow into the floor. That's how we get the static electricity off the body. So the standard, the ASTM standard, what we do is we measure the resistance that's been built into the shoes. So what we do is we place a shoe on a metal plate, we put an electrode into the shoe, and we measure the resistance. Historically, that resistance, if it was anywhere between 1 megohm and 100 megohms, it passed the standard. That standard from 1 megohms to 100 megohms did two things. One, what it did is it assured that the static electricity could flow off the body, but it also ensured that at a lower level that it provided protection against for the wearer in case they should touch an open circuit. So the 1 megohm minimum protected the wearer against touching an open circuit. Above 1 megohm up to 100 megohms allowed the shoes to bleed off the static electricity. Now, for the longest time, that was good enough, but within the last 10 years, what happened was some companies like AT&T that were making some very high-tech equipment said, you know what, that range is way too long, or too wide. So being a too wide range, they brought it down. They wanted manufacturers like us to bring that range down to much narrower. The ASTM committee has decided to have 3 standards: SD10, SD35, and SD100. So as a manufacturer, we can produce the footwear to any one of those standards. SD10 is the lowest standard and the narrowest standard, and that will probably become the preferred standard for most users of ESD footwear because it assures the manufacturer that they have the tightest and the lowest range. Now, below 1 megohm is we start to get into the conductive range. Now, conductive footwear is used by companies that are working in very explosive or the way I would describe it, where things can go boom. And so a good example of a company that might want to use conductive footwear is whoever makes airbags, because those airbags, that material that goes into the airbag is very explosive. So what they have to do, any static charge, even the slightest static charge, can create an explosion. Those companies will want to have or use conductive footwear. Conductive footwear essentially is like walking around barefoot. There is no resistance built into the shoes. So essentially, within the shoes, there's a conductive pathway all the way from the insert all the way through to the outsole. So as I said, conductive footwear, you're walking around barefoot, or another way of looking at it is your foot is in a bucket of water. You are always grounded, and static electricity is always bleeding off of you. Conductive footwear, though, does have one risk, which is it provides no resistance to the wearer in case they should come in contact with a charged circuit. So if they should touch an open line, they are subject to receiving a shock. But conversely, they are also then bleeding off electricity, so they'll never have any static charge build up on their body, which is, as I said, very important in environments where a explosion could occur. So ESD, or electrostatic dissipating footwear, is used in manufacturing situations where the control of static electricity is imperative to maintain the integrity or the quality of the product that's being manufactured. So let's just think about the cell phone that everybody has. Inside that cell phone are hundreds of microchips. And if a person should touch one of those microchips and a static charge comes off the body and goes through that microchip, it's like the lightning bolt coming out of the sky and hitting a tree. That static charge coming off of your body will blow up that microchip. Now, we don't know that it happened. We don't see it happening. It just happened. So the microchip then is placed into the phone. Phone goes through the final process. Somebody turns it on at quality control, and it doesn't go on. So static charges can be very destructive. Coming off the human body can be very destructive in the manufacturing process. So the folks that make this equipment have very strict static control processes in place. One of the best static control processes is ESD footwear, because what ESD footwear does is it allows that static charge that's building up on your body to constantly bleed off your body as you walk around. So the worker who's working with the microchip, as they walk around, their static electricity is always bleeding off the body. So if the static electricity bleeds off the body, then there's no static charge to go through the microchip. So ESD footwear is used as a method to make sure that workers are protecting the piece of equipment that's being manufactured. The ASTM committee has decided or has come up with a standard, and basically what we do is we test the electrical resistance that's built into the shoe, and what we do is we measure how much resistance is in the shoe. So if there's resistance in the shoe for static charges, works two ways. If the resistance is too high within the shoe, static charges can't bleed off your body. If it's too low, electricity can come from an open circuit into your body. So they set a lower range and a higher range. The low range protects you from an electric charge should you touch a live wire. The higher range sets the upper limit for resistance so that you want to be below the upper range, which allows static electricity to bleed off, and you want to be above the lower range so you're protected against a live wire. So the ASTM committee has set up a range between 1 to 100 megohms. Now the new standard has lowered that also to 35 megohms and to 10 megohms. So the new standard says there's SD10, SD35, and SD100. My estimation is most companies are going to head for the SD10 range, mainly because it's a narrow range, it's lower, and it gives more assurance to the manufacturer that they're protecting their equipment that they're manufacturing while at the same time protecting the wearer from electrical charges of an open wire. All right. I feel like I'm just wandering all over the place here, Matt. So now what?
Well, okay, so now
how would you just asked me a question, I'll go for it.
Yeah. So talk then about how Warson has attacked ESD footwear. So how you've attacked it from knowing the standard to what manufacturers are looking for, what you've done in your manufacturing process,
sure.
in your engineering process, I guess is the better answer.
Sure. So let me talk a little bit about how ESD footwear is made.